We are approaching the end of our course on calculus. This evening, we're going to be speaking about determining the equation of the cubic function. And it's a question that often gets asked in the exams. Often the way that it's structured is like the first question will say something like, given ax cubed plus 3x squared plus cx plus d, and they'll say something like show that a is 3 and b is 2 or whatever. So they normally ask you in that way, because then at least they're giving you the answers. If you can't do the working, then at least you can still use the information in the questions that follow. All right. Anyway, we're going to be even more basic than that this evening. Let me explain to you what it is that we're trying to do. All right. And it really has its roots back in the parabola. Okay. So let's just scooch over to the side here and just go up a little bit. Okay. Do you remember in grade 11, you were asked to find the equation of a parabola? So, for example, they gave you a parabola that looks like this. Okay, and let's pretend they gave you an x-intercept or two x-intercepts. So we'll just make that 1 and we'll make that 3. And let's pretend that they give you another point that lies on the line. So again, I'm just making up information here. Let's pretend that that is the point -2. That's the y-intercept. Do you recall the formula y equals a x minus x1 x minus x2, where you were given the roots and one other point and you had to sub in? Does that ring a bell? Do you recall that? Khomotso, just try logging out and logging back in again. Does that ring a bell, Matrix?
Offense agrees that it rings a bell.
Okay,
Tando
good.
also.
Offense, Tando, Naledi,
Nice, guys.
Barato. Cool. Okay. So what did we do? We did this. We subbed in our x-intercepts in place of x1 and x2. So we wrote y equals a, x plus 1, x minus 3. And then we subbed in our y-intercept as our other point. So that's the point 0 and -2. So we put the -2 over here, we put the a over there, and where x is, we've now got zeros. All right, so we've now got a bracket times a bracket, so that would give us -3, and we'd end up with -3a equals -2. So a is a bit of a horrible number in this case, but a would be equal to 2 over 3. And then if they asked you to actually find the equation of the parabola, you would then have to go and sub that a value back into your second line of working. So in other words, you would go y equals 2 over 3 in place of your a, and then you've got x plus 1 times x minus 3. And then you would have to FOIL out your brackets. So that would leave you with x squared minus 2x minus 3. Sorry, my eyes are giving me issues this evening. And then you would just have to multiply each of those terms by 2 over 3. So in the end, we would end up with y equals 2 over 3x squared minus 4 over 3x minus 2. Okay, we would end up with something like that. We're going to be using the same concept this evening, all right? But when it comes to parabolas, either they can have one x-intercept, which is also the turning point of the parabola, or two distinct x-intercepts. As far as a cubic function is concerned, it can have up to 3 distinct x-intercepts. So what we would do in a situation like this one over here is we would say that we can determine the equation when it's been given to us in the form y equals a, x minus x1, x minus x2, x minus x3. Does that make sense to everybody? that they could do that with a cubic function. I mean, after all, last week we saw that when we factorized, we could have 3 x-intercepts, 3 brackets being multiplied together. So does it make sense that we could have this now? Everybody happy with us? Yes? Okay. So sub in your x-intercepts first. So we don't know what a is equal to, so we leave it on the outside. So we're going to sub in our first x-intercept. So minus 2 would give us plus 2. Minus -1 would give us x plus 1. And sub in the last x-intercept, which would be x minus 4. Now we've got to use this other point over here. We've subbed in our x-intercepts. And now we've got to use this other point over here. It happens to be our y-intercept. So we are going to make y equal to -8 and x equal to 0. We're going to multiply the value of those 3 brackets together. So 2 times 1 times -4 is -8. And if -8 is equal to -8a, it means that a has to be equal to +1. And again, this makes sense when we look at the shape of our function because it's concave down and then concave up. So we knew that a needed to be positive. What we would then have to do is go and sub that a value back in over here. So where I'm highlighting it in yellow, that's where we would sub it back in. Okay, in this case, 1 is not going to change anything. So we've got y equals 1 times x plus 2 times x plus 1 times x minus 4. The easiest thing for you to do is leave the first bracket as it is and FOIL the second 2 brackets out. So this would give us x squared minus 3x minus 4. And now we're going to multiply our binomial with our trinomial. So we would end up with y equals x cubed minus 3x squared minus 4x plus 2x squared minus 6x minus 8. And last step, we can collect our like terms. Okay, so this would give us minus x squared, and that would give us minus 10x, and then we would have our -8 at the end over there. Is everybody happy with that? Does that make sense? Thumbs up, thumbs down, how are we feeling? So when there are 3 distinct x-intercepts, use what I have given you in black over here. All right, so this is for three distinct x-intercepts. We would use what was given in black. Okay, good stuff. All right, so I'm going to give you one to try. So take screenshots if you need to. And we're going to go down and we're going to go and have a look at this question. And that's this one over here. Okay, so you are going to work out what the coefficients of the x cubed, x squared, x, and the constant term are using the information that's been given. All right, off you go. sure some p-ware. Okay, just sorry, everybody. There you go, some p-ware. Screenshot. And we'll go back to it right now, everyone. No problem. There's the question. There we go. And then when you're done, just pop done into the chat.
You can take your phone.
Let's remember to stay muted.
So Buyo, when you sub in a negative x value, the sign will change because it's x minus inside the brackets. Okay. So the sign will always change. And if you think about it, it makes sense because we have to go backwards because remember we're taking it over the equal sign. Okay, so it's x minus x1, x minus x2. Okay, so it is minuses for all of them. Okay. So again, remember when you're solving, if you had x minus 3, then if that was equal to 0, you'd have x equal to 3. So that's why the sign changes when we go back into the bracket. Okay. Are we getting done here? Well done. Intlafatso, Trish, Z, Cloggy, Keith Lynn, Sanipa, Tondo. Good job, everyone. Well done. Fence is done as well. Okay, so there's quite a few of you that are done. Well done. Nicole, Santlantla. All right. Do we have a volunteer to tell us how we did this? Anybody willing to share their answers with us? Don't be shy, Matrix. Are you guys tired tonight? Nobody wants to talk. Okay. That's fine. I'll tell you what I did and you can check your answers. Okay, so you would have subbed in x minus 6. You would have subbed in x minus 1. You would have subbed in x plus 2. Then in place of your x and your y, you would have made y equal to negative 12, and you would have made x equal to 0. When you multiplied your 3 brackets together, you should get positive 12a equals negative 12, and a should be equal to negative 1. No shame, Bonga, I understand. I understand. That is a hectic day. All right, so Bonga, hopefully now you took that minus 1 and you subbed it into the line where you've got x minus 6 times x minus 1 times x plus 2. And when you're dealing with a negative, it's just easier to leave the negative on the outside for now. So sorry, I haven't written that very well. Let's just fix that up. We'll leave the x minus 6 there. We'll FOIL out the other brackets. That would have given us x squared plus x minus 2. And I'm going to leave the negative on the outside, and I'm going to multiply the, yeah, no, that is hectic, hey. All right, so that gives us x cubed plus x squared minus 2x minus 6x squared minus 6x plus 12, and nearly there. That would be x cubed minus 5x squared minus 8x plus 12. And when we finally removed our brackets, we would get negative x cubed plus 5x squared plus 8x minus 12. How did that go? Did you guys get that correct? Thumbs up, thumbs down, questions? Cool. Nice. Oh, lovely. Good, Chloe. Good, Nicole. Good, Z. Good, Keithlyn. Tando's got it. Naledi's got it. Latifa's got it. Trisha's got it. Lefatso. Chloe, good question. How many marks would something like this be? Okay, so there would have to be a mark for subbing in the x-intercepts. Maybe 1 mark for both the x-intercepts and that other point. An accuracy on the CA, subbing it back in, multiplying it all out. So yeah, maybe 4. Okay, Chloe. All right, so let's move on if there are no questions, and let's talk about what happens in a situation where a turning point is also an x-intercept. All right. So what happened when a turning point was an x-intercept with a parabola? Well, I'll just quickly sketch one here on the side for you. If you had a graph like this one, and let's pretend that this is the graph of g of x, and it is the graph x squared minus 4x plus 4. If I wanted to solve the x-intercept of this graph, I'd make y equal to 0. And then when I factorized my brackets, I would have a situation like this, right, which can also be written in this way. Okay, so when I have an x-intercept that's also a turning point, my bracket is going to be a square. The same thing applies in the cubic function. So in other words, what we do is we adapt what we've got. So we've got y equals a, x minus x1, and then here we've got x minus x2, and we're going to square our bracket. All right, now the other difference in this particular question here is that they have already given you the value of the number in front of the x cubed term. They have told you that it's equal to -1. So we can actually get rid of this, and we know that it's equal to -1. They've told us that. Okay, so what we would end up doing is this. We would write y equals -1, x plus 3 times x minus 2 squared. And then we'd have to do what we did above. Okay, we would multiply everything out. As follows. Okay, so we would leave the negative on the outside. Silly me. So this is the easy bit. And finally, we would finish it off as follows. Does that make sense to everybody? Any questions? Thank you, Keith Lynn. It does. Cool, Tando. All right, so the point that I'm making is that when an x-intercept is also a turning point, the bracket must be squared. Okay, so it's the bracket, the only bracket that's squared is the one that you sub the x-intercept that is also a turning point into. Okay, the bracket, if it's like so for example, this x plus 3, it's not a turning point, so that bracket's not squared. Hello, Tsegofat, so how are you?
I'm good, and how are you, ma'am?
I'm fine, thank you.
I wanted to ask if would they give us the turning points, like tell us the turning points on the graph, or will they just tell us in a statement, in a question?
So what they can do is they can either show it to you on a diagram, or they can give it to you in a statement. So a good illustration of this would be a question like this one over here, right? Let's have a look at question C.
Okay.
Okay, so I really like your questions. If we have a look at question C, everybody, here they've told us the graph of y equals minus x cubed plus ax squared plus bx has a local turning point at 2 and minus 32. Find the value of a and b. So they could do something like that.
Okay, ma'am.
Okay. Would you know what to do in this case, Tegofatso?
Yeah, we just draw the formula in that form of a bracket x minus x1 and bracket and then x minus x2 and then substitute the turning point with the square.
Okay. All right. But if you do that in this particular situation, you'd end
Yeah.
up with this. Y equals, okay, so you know that that's -1. So you've got x minus x1. And then over here, you'd have x minus, oh, but hang on. You know what the problem, you can't do that. Okay, sorry.
Yes.
Do you know why that's not going to work?
Yes.
The reason it's not going to work is because you don't have any x-intercepts. You only have a turning point.
Oh, turning point. Oh, I see.
Okay, but we'll come back to this. Okay, so now somebody just asked me to go up to the previous question. Let me just go back up here again. Any questions here? Are you taking screenshots? I'm going to move on. No questions? Are we all good? Okay. All right. Okay. So let's have a look. Let's have a look at a question like question C, right? Now here's something completely different. You are not given any x-intercepts in question C. So unfortunately, what we were doing in the first couple examples are not going to work in question C. We've got to think of something else that's going to help us. All right. They want us to work out the values of A and B. Usually when they give us variables, they want us to work something out simultaneously, right? Okay, so here is another way of being able to find the equation of a cubic function, only now you don't have any x-intercepts. You've only got one turning point. The first thing, yes.
Hi, sorry.
No problem.
Can you not derive the formula and make it equal to
Aha.
0?
Beautiful. Why are you doing that?
Well, if you derive it, it becomes a parabola, I guess. And then the parabola, the x-intercepts of the parabola equal the 2 turning points of the
They do. They
cubic
do. They do.
function.
Absolutely. That's very
Then-
true. That's very true. But, you don't know what the x-intercepts are. But I like what you
Yeah,
said
so
in the
do-
beginning. Sorry.
yeah.
So I
Can
like
you-
what you, sorry. Go
No,
for
you
it.
can
You
carry on,
talk.
ma'am. It's okay.
Please go ahead. Sorry.
Can you then derive it and then sub in the x values of the thingy and then make it a simultaneous equation?
That's it. That's it. That's it.
Okay.
So, yeah, perfect. All right. So we'll just run through that quickly about what you would do in this particular situation. So you would derive it, like you said. That would give you minus 3x squared plus 2ax plus b. Nicole, you've got a hand up.
Hello, ma'am.
Hello.
I have a question here.
Go
The
for it.
other person said that you have to derive this formula and equate it to 0. Don't you
Yes.
think that equating it to 0 is incorrect? Because like when we equate to 0, the statement will be given that the gradient is 0. So here they didn't tell us that the gradient is 0.
Okay, so do you know what? She's absolutely right in what she said. The reason, and I love your question. Can you see here, Nicole? They've told us it is a turning point. What is the gradient at the turning points? So for any cubic
It's 0.
function, it's 0. Exactly.
Okay.
Exactly. So whether your cubic function was shaped like that, or whether your cubic function was shaped like that, at your turning points, your gradient is 0. Okay, so she's quite right in what she said over there. What she would still need to do, however, is she would have to sub that 2 in. So she's going to make the gradient equal to 0. Here she's going to have minus 3x squared plus 2 times a times 2 plus b. Sorry, I'm being silly now. I should have put a 2 there as well.
Sorry, one more question. Why would you not make it equal to negative 32?
Because you are working with the gradient. Okay, y
Okay.
is equal to negative 32 when x is equal
Yes.
to 2. But f of x, f prime x, or
Yes.
dy over dx is equal to 0 when x is equal to 2 because it's a turning
Okay.
point. Does that make
Okay,
sense to
thank you.
you?
Yes.
Okay.
Yes, it
So
does.
you are going to, yeah, so you are going to do that as well. So this is going to give you one equation where you work with the derivative. So in other words, now you've got negative 12 plus 4a plus b. So that would be one equation. And then you would get the other one by subbing in the point. So you would put in the negative 32, and then you would have negative 2 cubed plus a times 2 squared plus b times 2, and that would give you your other equation. Okay,
Thank you.
cool. All right. Okie dokes. So now we've got negative 32 equals negative 8 plus 4a plus 2b. And I suppose both of these could be arranged a little bit better. This would give us 12 equals 4a plus b. And here, if we add 8 to both sides, we are going to end up with negative 26, negative 24, sorry, would be equal to 4a plus 2b. All right. And now, matrix, you can solve simultaneously. So if you want to, you can solve by substitution, or you can solve by elimination. I love elimination for these sorts of questions because I just think it's quicker and easier. Totally up to you. All right. Any method of solving simultaneously would be okay. I'm going to do elimination if that's all right. Why is this thing doing this? There you go. Go over there. And then I'm going to put my other equation underneath. And I'm going to eliminate my a term. And it's 4a in both. So I'm going to eliminate by subtracting. And that's going to give me 36. My a terms are gone. And b minus 2b would leave me with negative b. So b would be equal to negative 36 in this case. Okay, and then you're going to have to go back and sub in for a in any event. Okay, so going back, we would end up with 12 is equal to 4a plus b. So that would be minus 36. And that would give us 48 is equal to 4a. So a would be equal to 12 in this case. All right. How does everybody feel? Is that making sense to you? Are we all good? Good stuff. Oh, good. Oh, good. I'm glad it makes sense to everyone. Okay. Kamogelo, you got a question?
Hi, ma'am.
Hi, Kamogelo.
Could you please scroll up a bit?
Sure. Is that enough?
Yes, thank you.
No
Could you
problem.
please explain to me from the first step? I just kind of didn't understand that part.
Okay. That's fine. What I'm going to do is I'm going to explain this to you, and I'm going to give the others something else to try. Okay. So everybody else, while I'm explaining this to Kamachelo, why don't you choose either D or E to do? Let's just see how we're going to get all of this onto the same. Okay. All right, let's do it like that. Okay, so while I'm explaining to Kamachelo, everybody else, you can pick either try question D or you can try question E.
Sorry, ma'am.
Okay. Mm. Okay, so Kamachelo, in this particular question, they haven't given us any x-intercepts. They've only given us a turning point. Okay, so we know that at any turning point, the gradient is going to be 0. Right, so that's why I took the first derivative. In fact, let me just get rid of all of this. I can do it again, that's not a problem. Okay, so I took the first derivative. So that's why I've written dy over dx, my first derivative, and then I've derived. So I've now got minus 3x squared plus 2ax plus b. At my turning points, the gradient is 0. So the gradient is equal to dy over dx. Okay, it's going to be 0 at the turning points. That's why I'm making dy over dx equal to 0.
Ma'am,
Then,
before we continue, my first confusion is, where does the negative 3x squared plus 2ax come from?
okay, so you've derived. So you're multiplying the exponent by the coefficient and then taking one
Oh.
away. You're applying your power rule.
Now I see it, ma'am.
Okay, does it make sense to you now?
Yes.
Okay. And then does the rest of it make sense to you? Or is it just that
Yes.
confused you?
That was my confusion. So now I see that we have derived, and then it's just minus
Yes.
3, like 3 times the negative, 2 times the a, and then it's gonna be 2ax and then plus b.
Yes. Yes. Okay. Do you want me to do the rest of it for you?
Yes, please.
Okay. All right. So now you know that when the gradient, you know that at x equals 2, you know that dy over dx is equal to 0. You know the x coordinate where the gradient is 0. So what we can do is we can go and sub that x coordinate in here so that we've got an equation in terms of a and b. So this would give us minus 12 plus 4a plus b. And if I take my number over to the other side, I'd have 12 equals 4a plus b. And that would be your first equation, Kamachelo. Okay. Now, the other thing that you can do with the information that they've given you, sorry, let's get rid of all of this, is you can sub in that point into your equation. Okay, so you use the point, use the derivative, make the gradient equal to 0 and sub in what your x is. And then you can also sub the point into the equation. So in other words, you are going to replace this y over here with negative 32. And you are going to replace the x with your 2. And you're going to end up with negative 32 equals negative 8 plus 4a plus 2b. And again, if we get it into a form where our number is on the other side, we would end up with negative 24 equals 4a plus 2b. Okay, sorry, I just want to go up in case anybody's still looking at this question over here. I'm
It
just
makes
moving it,
sense now,
everybody.
ma'am.
Does it make sense now? Okay, and then you just have to solve those two equations simultaneously. Okay, so this one over here and that one over there. All right, Kamogelo,
Thank-
are you happier now? Hope so.
Thank you so much, ma'am.
It's a pleasure. It's a pleasure. No problem. Do you want me to explain the solving simultaneously, or you've got it from here?
I've got it from here, ma'am.
Okay, cool. All right, no problem.
Hello, ma'am.
Hello, how are you?
I'm good, and you?
I'm fine, thank you.
I have a quick question.
Sure, Katlego.
Ma'am, at the when you're doing the elimination method, I was confused why it was negative 24 instead of just negative 24.
Okay, because what I did here, Katlego, is I took my -8 over to the other side. So you see this -8 over here?
Yes, ma'am.
It
I
went,
understand why it is negative 24, but I was just confused why it was minus 24. Like, why
Oh,
was it?
okay. So in other words, you've got 12 equals 4a plus b at the top. And then I've
Yes.
put -24 equals 4a plus 2b at the bottom. Okay, so what I'm doing, Katlego, is I'm eliminating my a terms. So if I want my a terms to be eliminated, I have to minus, not subtract, not add. Okay, because if I'm adding, then it would be a 4a plus 4a, which would be 8a. So that's why when you eliminate, you can either eliminate by adding equations together, or you can eliminate by subtracting. So if the term that you want to eliminate, if the signs of the coefficients are the same, then you have to eliminate by subtraction. So that's why I did this. Because what I want in this A column is 4a minus 4a, which means my A term is gone. So that's why I've got minus minus. Does that make sense to you?
Yes, ma'am. Thank you.
Okay, so now your A term is eliminated, and now you've got b minus 2b, which is where the negative b came from.
Okay, thank you, ma'am.
It's a pleasure. Hopefully the rest of you are okay. Okay, when you're done and you think you know what the values of m and n are, or if you think you know what the values of b and c are, then you're welcome to put done in the chat. Okay, so Tsegofatso. Good. That is indeed correct, Tsegofatso. Well done. Good job. Okay, so I know about 2 people that are done. How's everybody else coming along here? Almost done. Oh, okay, sorry, I didn't mean to chase you. Okay, cool. Cool, Tando. So, Sinantlanhla's done, Keithlin's done, Trish is done, Tando's done. Well done. I'm just slowly working through it, just in case there are any people with questions. I don't know, am I doing the right thing here? I think I'm trying to do too much all in one go. All right, let's just finish this off quickly. So we've got one equation over here. The other one would be the derivative. So we would have dy over dx. That would give us 3m x to the power of 2 minus 6x minus 12. N would be seen as a coefficient. So you know that the gradient is 0. We would have 3m. That was a 2 squared minus 6 times 2 minus 12. And we'd be able to solve for m. So that would give us 0 equals 12m minus 12 minus 12. So that means that 24 would be equal to 12m. So m is equal to 2, just like you said, Sechofatso. Okay, and then when we went back up here and we want to solve for n, we would have 33 equals 8 times 2 plus n. So that's why n would be equal to 17. Okay. All right. So that's cool. Anybody try question E? That's question D. Anyone try question E? Were there any takers for question E? If you did do question E, B is equal to 1 over 2, and C has a bit of a nasty value. You're still doing it, Tegofatso. Okay. I'm just giving you the answers. This is horrible. Okay, so if you do want to do E, that's what you would get as your answers for B and C. They're not very nice values, but that's what you'd get.